We are going to continue with using normal distributions. We are on part 2, and this is example 3, using a z-scored and a standard normal table. A study finds that the weights of infants at birth are normally distributed with a mean of 3,270 grams and a standard deviation of 600 grams. An infant from the study is randomly chosen. Use a z-score to find the probability that the infant weighs 4,170 grams or less. All right, if you're like me, you're kind of curious, what is 3,270 grams equivalent to in pounds and ounces? 3,270 grams is about 7 pounds, 2 ounces for all those curious minds. All right, now let's use the z-scored. All right, so z equals some x value minus the mean over the standard deviation. Remember, that's one of the formulas we looked at when we were looking at definitions. All right, so we are given, study finds a weight of infants at birth normally distributed with a mean of this, a standard deviation, and what's the probability that the infant weighs 4,170 grams or less. So the 4,170, that's our x value. That's what we're trying to figure out. So we're going to say this equals 4,170 is our x minus our average. Up here it says our average is 3,270, and it's over our standard deviation, which is 600. All right, so let's pull up our calculator and see what that equals. So we got 4,170 minus 3,270, and then divide that by 600, and we get a z-score of about 1.5. All right, so now it says use a z-score to find the probability that the infant weighs this. So there's something called a standard normal table. So you can find this standard normal table online if you just type in standard normal table, and it's going to give you a normal distribution table. So give me a second to get that. All right, so this is not the entire standard normal table. This is just the part that we need from your textbook. So you can see that 1.5. So if we go down to z-scored, it doesn't have 2 and 3 on here, but if we go down to 1, which is all we need, and come over to 0.5, it's about 0.9332. So that means there's about a 93.32% probability that a baby will weigh this many grams or less. All right, so I told you 3,270 grams is about 7 pounds, 2 ounces. 4,170 grams is about 9 pounds, 3 ounces. So that should make sense that the average weight of a newborn is 7.2 ounces. And it should also make sense that about 93.32% of babies weigh less than 9.3 or 9 pounds, 3 ounces, or that's equivalent to 4,170 grams or less. So that's how you use the standard normal table along with your z-score to find a probability. Example 4, recognizing normal distributions. Determine whether each histogram has a normal distribution. All right, if you remember in previous lessons, we talked about normally distributed or a normal bell curve, and then ones that were skewed left or skewed right. So it's very important to remember that if you have data or you have a histogram that is skewed left or right, if it's not symmetric about the mean, if it's not normally distributed, you cannot use the normal distribution methods that we've been talking about to do these, to figure out percentage of data or do probability on the data. So A part here, heights of women in the U.S. ages 20 to 29. And here is the relative frequency. All right, so this is heights in inches, and you can see it goes up and it comes back down. Most of the data here is in the middle. It's not perfect, but this one is kind of symmetric about the mean, which would be the middle of the data. So in my mind, A part is bell-shaped and it's fairly symmetric. So the histogram is approximately normal. So this, you would be able to use a normal distribution curve to get estimates about percentages or numbers that you may be looking for. B part, on the other hand, if you see most of the data is on the left-hand side, which means it is skewed to the right. If you look here, we've looked at this before. This is skewed to the right, so you could not use the normal distribution curve or the 68, 95, and 99.7. You could not use the empirical rule or the z-score to find out any information about this histogram. You could use the table given to look at certain percentages for different age groups using their frequency. So you could get some information just from the table, but you cannot use your normal distribution curves to find percentages based on a normal distribution curve. Okay, that's all for today. If you have any questions, please let me know.